All the components of concave mirrors that we've discussed in the past few weeks relate to each other in the most outstanding of ways. And if you were in high school taking math classes that were kind of advanced like trigonometry and geometry, I would show you the proof. However, since that would just confuse you, I'm going to give you these equations and talk about the signs, the positive and the negative, and how as optics people, how we've chosen to denote that. So the first equation relates the focal length and the distances of the object and image, and it looks something like this. 1 over f equals 1 over do plus 1 over di. And in this equation, f represents the focal length. Okay, so in a concave mirror, remember there's a center and then halfway, so this is the radius. This distance right here is the radius. Half of the radius, this length is the focal length, so we call that f. All right? Now, d with a little o underneath it. D stands for distance. So we want to know the position of the object and the position of the image relative to the concave mirror. So d sub o, that o stands for object, so it's the object distance. Okay, that's normally how it is in physics. You write like d to represent distance, or h to represent height, or t to represent time, and then any subscript you put under it just specifies what you're taking the time or the position of. So in this case, you're taking the distance of the object, and di would be the distance of the image, so the image distance. And we'll work out about 4 problems that relate all these together. The second equation, so this is more commonly known as the mirror equation. So the second equation is part of the mirror equation. In fact, you actually use this to derive the mirror equation, but we call this the magnification equation. The magnification equation. And here's what the magnification equation says. The magnification equals, and I call this the hi-ho equation. Here's why. H sub I over H sub O, which is also equal to negative d sub I over d sub O. Now a lot just happened, and I'm going to define all these variables for you. M stands for the magnification. If it gives it to you in a problem, which not very often that it does, if it says the magnification is 2 or 1/2, it essentially gives you this ratio. Okay, H sub I, well, H stands for height, and I signifies that you're taking the height of the image, so that's image height. All right, and HO is object height. So you put a pencil in front of a concave mirror, how tall is it? All right, I'm not going to bother putting DI and DO again. It's the same object and image distance. But one thing that you are going to screw up on, I can predict the future. If you're going to screw up on something, ever, it's going to be this negative sign right here. And there's a reason for that negative sign, but I can't really get into it with you all. But we need to talk about something called a sign convention. Okay, sign conventions. In physics, you do this all the time. The equations just exist because we've set up a situation in which things are defined. For example, in algebra class, you might have learned about the Cartesian coordinate system and how this is the x-axis, or the horizontal, and this is the y-axis, or the vertical. Okay? If I move to the right, does my x get bigger or smaller? Do I have positive numbers or negative numbers? Well, I pray that you said that if you go in this direction, if you go to the right, that's positive. And if you go to the left, that's negative. If you go up, that's positive. Down is negative. Why? Can you give me a good answer of why? Well, it's just intuitive. Like, oh, I move 5 meters to the right. You kind of think of that as positive. Does it have to be? Absolutely not. I could just as easily say that every time I move right, I decrease. Okay, so this would be -1, -2, -3. And every time I move to the left, that's +1, +2. What if I took this entire picture, and I know you can't see my hand, but take your hand, whether it's palm facing you or out from you, and just flip it 180 degrees. Okay, so you have your hand right in front of you, and that's a coordinate system. If you flip it 180 degrees, then everything kind of changes, and you actually get this exact coordinate system that I defined. If you move to the right, that's actually negative. If you move to the left, that's positive. Everything kind of switches. So I want you to be aware that in physics, all the time, we do sign conventions. We assume that going one way is a positive and going the other way is a negative. If you want to change that for whatever reason, you have to change both sides. So if I'm going to make this side the positive x-axis, this better be the opposite. If I want to change, I have to change both the left and the right directionality. Basically, sign conventions for us are going to talk about each of these variables. So I'm going to talk about each of these variables with respect to whether they're positive or negative and when they're positive and negative. So I'm going to go and do that under here. Okay, let's talk about the focal length. Okay, the focal length for concave mirrors is just always positive. So it's always positive for concave mirrors. Now we're going to talk about another mirror type called convex. Okay, but here's a concave mirror, and any distance, I kind of like to think about this as kind of like a cave. That's how I remember it, like cave, concave. This looks like a cave. And if it's inside the cave, it's positive. Now, convex goes the other way. Kind of goes the other way. But if you have a focal length that goes the other way for like a convex mirror system, that's negative, but you don't have to worry about that. So for right now, the only thing you need to know is focal length for concave mirrors is always positive. Right? My drawings are just getting worse and worse and worse. So I have some object that's placed right here, and there's a center, and there's a focus. That's the radius. That is my focal length. All right, let's talk about the object and the image distance. Okay, here's the thing. If it's positive, you're moving in this direction. That's the positive direction. Again, I talked about how this is a cave, and if it's kind of inside the circle, it's positive. But we can actually have distances, and you saw in the previous video, that were outside of this mirror system, okay, that formed a virtual image. Okay, that would be considered a negative distance. So in your calculations, if you ever get DO or DI to be negative, then that is outside this mirror. It is to the right. Okay, so I'll denote that it's positive for inside the concave mirror, and it's negative for outside. I know those terms are kind of arbitrary, but again, what I mean by inside and outside, this is the inside, in, and this is the outside, out. Just kind of absorb that for just a few seconds. All right. Finally, we need to talk about the height. This one's probably a little more intuitive. A little more intuitive. If you have a positive height, that means the image is upright. Okay? This would be an example of upright. Think of a person just standing on this. If your height is negative, then your person is inverted. I'm not even going to try to draw that, but right? Inverted. So if you have an image that's negative, if you get a height that's negative, you know it is below the mirror system. All right, my plan was to do a few practice problems, but I can imagine that I kind of overwhelmed you. Don't worry about memorizing these. These will be on your reference sheet. In the next video, I hope to actually go through some examples. But I hope you understand this is the most important thing. This negative sign right here, don't forget it. If you have a negative image distance, that negative still goes there, and then you put the negative, whatever your distance is. Let's say it's 5 centimeters, and you get -5. Well, this negative is still here. Negative times a negative gets you a positive. Don't forget that in your calculations. Finally, we talked sign conventions, and I defined what we're going to use. Now, arbitrarily, you can use whatever you want. You could say it's negative for concave mirrors for all I care, but I'm just using the most popular sign conventions that you see in a lot of textbooks. And that's the one that I always go through, but you can technically define it however you want, but you're not mature enough to do that for yourselves, because I'm not mature enough to do that for myself, so we're just going to stick with these guidelines. All right, I hope to see you in the next video where we actually do some calculations.